In this video, I'm going to walk you through the routing process with a very simplified network design where we have two LANs and one wide area network link with two routers. So this is going to be your introduction as to how routing works. So let's take a look at the diagram so you understand how it's designed. What you're going to notice over here is we have a network that is a 192.168.1.0/24 network. This is a local area network which has one PC, one switch, and one router. And then over here, we have another local area network, which is a 192.168.0.0/24 network, again with one PC, one switch, and one router. And then in between, we have a connection from both of these routers connecting them together. This is going to be a wide area network link. So this utilizes a 200.100.100.0/24 network, which again is a standard class C network. And what you're going to notice is that within the network on the routers, it says Ethernet, but between the routers, it says serial. So when you're working with Cisco Packet Tracer and the routers, when you're connecting the wide area network portion, it's going to be a serial connection. But within the LAN itself, well, we use Ethernet and we use our Ethernet cables. So what I want to do with this diagram is walk you through a very simplified process of PC1 sending a packet all the way over to PC2. So how does that work? Well, let me get rid of all the highlighting first. So the first step in this process is PC1 creating a packet that's destined for PC2. And when it does that, that packet's got to include its source IP address, which is the IP address of PC1, and the destination IP address, which is the IP address of PC number 2 on the other network. Now, also it's going to include the data, but in terms of the routing process, we're concerned with the IP addresses. Now, because this is going to be destined for a computer that's on a different network, what it has to do is that it's got to be sent to router number 1, which is PC1's default gateway. And so what it does is it sends that to its Ethernet interface on router number 1, which is this IP address right here, 192.168.1.1/24. That's actually going to be the default gateway configuration on PC1's TCP/IP configuration. So it's going to know that it needs to send it out of this interface on the router because, well, that's the default gateway. Now, what happens if for some reason PC1 doesn't know the MAC address for router number 1? Because remember, the switch is going to utilize MAC addresses, and then once it gets to the router, it's going to inspect the IP addresses. So if for some reason this is the first packet that PC1 is sending to the router, and it doesn't know the MAC address for the default gateway, well, it can simply just send out an ARP request and find that out, which we've already talked about how that works earlier in the course. So that's step 1. Now let's go ahead and let's take a look at step 2. So moving on to step 2, we now have a packet at router 1 because while PC1, it sent that packet destined for its default gateway, which is router number 1. So let me go ahead and draw in an envelope to signify this packet sitting here at router 1. And router 1 needs to determine how to get it over to PC2. So let's talk about how that works. So when PC1 receives that packet, it's going to inspect the packet and specifically the destination IP address within the packet and then make a routing decision. And it's going to look in its routing table to identify which route it needs to send it to. So what I've done on this Cisco router is I've done a show IP route command to show the routing table. And what we need to take a look at is we need to figure out how to get over to this network, this 192.168.0.0 network. We need to figure out how to get there. Well, if we take a look at the routing table, and I've already put an arrow there, we can see to get to the 192.168.0.0 network, we have to go through 200.100.100.254. So if we take a look at this diagram, you're going to notice, and let me go ahead and put an arrow, this is going to be where it needs to go right here. And of course, it's already signified up here. So we know that we need to go from here to this interface. And I said this was a very simple example because, well, there's only two routers. But let's assume that there was a third router or a fourth router. Well, then router 1 would have to look at the routing table and determine the most efficient manner to get it to router number 2 to deliver it to PC number 2. But in this example, it's just going to be this right here. So what it's going to do, it's going to forward it on over to router number 2, and then router number 2 is going to get it. It's very simple. Now, a couple of other things on here. You're going to notice down here within the routing table, there are a couple of other entries. There is this one that we see right here, where it's 192.168.1.0, and it says that's directly connected. That's because on the router, this is the Ethernet IP address that's connected directly right there. And then also, you're going to notice directly below that, there is the 200.100.100.24 is also directly connected because, well, that's going to be directly connected right there. And that's why one of them says fast Ethernet and the other one says serial, because this router has two interfaces, one for the Ethernet side for the LAN, and then one for the WAN side, which is the serial interface. So now we know that this packet has now gotten from router 1 all the way over to router 2 because router 1 made an intelligent decision by taking a look in its routing table to route that packet over there. Let's now move on to step 3. So moving on to step 3, we now know that the packet is over at router 2. So let me go ahead and draw in our envelope up here. So router 2 now needs to do a similar process to router 1. It needs to take a look at the destination IP address, and it needs to determine, do I need to route this on to another router, or do I need to send it within my network? So it takes a look at the destination IP address, and it makes a routing decision based upon its routing table, just like router 1 did. So you'll notice that we have the routing table down here, and it's going to take a look at the destination, which is this address right here, 192.168.0.2/24. And so it knows that that's going to be part of this larger network. So if we take a look at the routing table, it's going to show it that it's directly connected on its fast Ethernet 0/0 interface, which is this interface right here. So looking at this one right here, this specific entry, it shows that 192.168.0.0 is directly connected to the router. So what that tells the router is that this is going to be destined for its local area network that's connected to it. If it wasn't destined for that, then it would send it out to another router, and it would continue this process until it reached its final destination. Now, what happens after this? Well, the router's going to go ahead and it's going to ship it in to the local area network over to the switch. And now it's the switch's job to do the end delivery over to PC number 2 using its MAC address. So that's the process in a nutshell. And I know that routing can be much more complex than this, but I wanted to do a very simplified process with only 2 routers. So hopefully this was beneficial and it helped you to better understand the routing process. If you have any questions as to what we talked about, please let me know. If not, thanks for watching, and I'll see you at the next video. Take care. Well, I hope that you enjoyed today's video and you learned a lot from it. If you did, please give this video a thumbs up and also consider subscribing to my YouTube channel. Now, if you're interested in taking this full course or just learning more about it, check out the video description down below because I've included a link where you can learn more about the course and enroll into it if you'd like. So again, thanks for watching my video. I appreciate it, and I look forward to seeing you guys at the next video. Take care.